Hello everyone. In this video we will see some clipping circuits. This is the first clipping circuit already we have discussed. Once again quickly I will take this one. Here Vn is 0. Vn is 0 but Vp is Vi. For forward bias operation of the diode Vp must be greater than Vn. That means here Vi is greater than Vi. Diode is under forward bias. It can be replaced by short circuit. So output is equal to, you will get 0 because you are taking output across the short circuit. Next, to get the reverse bias, you have to take Vp is less than Vn. That means Vi is less than 0. That means output voltage is equal to input voltage. So how you are getting the output? This is the input I have taken. So to draw the output, we have to take output for the negative values of the input. So like this we will get. But for the positive values of the input, output is 0. Like this we'll get. And these waveforms are changing with respect to time. And if you want the transfer characteristic curve also, we can able to draw. Where for the positive values of VA, output is 0. For negative values of VA, output is equal to input. Okay, this operation we have seen. Now, we'll take another circuit just by providing reference voltage to this particular above circuit. So instead of making inside is grounded, here we have taken VR voltage, that is non-zero. So this is equal to 2 volts. Now across this one we have to take output and input is provided here. And this is R diode D. Okay. Then what is the circuit operation? Here Vn is fixed at 2 volts. Previously Vn is equal to 0. And Vp is equal to Va as compared to the previous case, it is also same. So when will you get forward bias for the diode now? We can get forward bias when Vp is greater than Vn, that is 2 volts. But Vp means what? Vi. So whenever Vi is greater than 2, diode will get forward bias that can be replaced by short circuit. So at that time, what is the output you will get? Diode short circuited, here 2 volts battery is there. So output you are measuring here. So output is equal to 2 volts you will get. That means when input is greater than 2, output is exactly equal to 2. Okay, I will highlight that one, then you can concentrate on that one. When VA is greater than 2, output is equal to 2. That means when VA is 2, 3, 4, 5, 5, 4, 3, 2, output you can able to take 2 volts. Okay, then for the reverse bias operation also you can able to check. For reverse bias, opposite case you have to take. That means VA is less than 2 now. So when VA is less than 2, VP is less than VN. We are satisfying that condition. Okay, Vp is less than Vn. That means reverse bias condition. So diode can be replaced by open circuit. So if you open circuit the diode, what will happen? Diode is there, but that is acting as open circuit. Here 2 volts battery is also available. So now what is the output voltage? Input voltage is there, which is less than 2. Here resistor R is also available. So one thing you have to remember, since it is open circuited, there is no current flow. If current is not available, you no need to consider that particular element. So current is not flowing through the battery 2 volts. Current is not flowing through the resistor R. So these two are not taking any power. Okay, because current is equal to 0. So you no need to consider them. So if you apply the output voltage in parallel with the input. Okay, if you apply the KVL, you will get a V0 is equal to exactly VI. So what is the condition here? When VI is less than 2, output is equal to input. V0 is equal to Va. So if you want to see the waveforms here, so input waveform I am taking for the reference. This is the input waveform with respect to time, and I am going to draw this transfer characteristics also. And since we are comparing with 2, I am making here 2, here also 2. Now I will draw the outputs. So what is the transfer characteristic equation? VA is greater than 2, output is 2. So for example, it is 2. VA is greater than 2 means the above this particular mark, whatever the input is there, that is greater than 2. So output is equal to 2. But for the input levels which are less than 2, output is equal to input. So exactly we have to take this one. Okay, if you see the above circuit, reference voltage is 0. We can consider this this circuit as the reference voltage is equal to 0. For the reference voltage is equal to 0 is done. And second circuit is for reference voltage is equal to. What is the common property of these two? The portion of the input signal has been clipped above 0 volts in the first case, above 2 volts in the second case. So commonly we can tell the portion of the input signal has been clipped above reference voltage. Okay, in the first case reference voltage is 0, in the second case reference voltage is 2. So commonly we can tell the portion of the input signal which is above 2 volts has been clipped. Now I will take another circuit which is having the reference voltage negative voltage. Same diode but negative reference voltage we have taken. Minus plus, this is minus 2 volts actually. So output we are taking as it is here, a resistor, and this is VI. So like this we are taking. So now when we will get the forward bias? Here Vn is equal to minus 2 volts and Vp is equal to Vi. So we can get forward bias when Vi is greater than minus 2 volts. Okay, forward bias. Forward bias means diode is replaced by short circuit. Diode is replaced by short circuit. Then what is the equivalent circuit for this one? Diode is short circuit and here we will get battery. Like this we will get. Okay, this is equal to minus 2 volts. So output is equal to minus 2 volts we will get. Because output is taken across the battery minus 2 volts. In parallel, output voltage, voltages are same. So when VI is greater than minus 2, output is equal to minus 2. Okay. Now the second case is, since we have completed VI is greater than 2, the second case is VI is less than minus 2 volts. When VI is less than minus 2, we'll get reverse bias condition. That means the diode is available, but that has to be replaced by open circuit. Then the resultant diagram will be like this. Diode is open circuited. Here battery is there. As I said earlier, if there is no current, you no need to consider that particular element in the circuit. So no current, no voltage across the resistor according to Ohm's law, no current through the battery, you no need to consider this minus 2 volts also. So output voltage is in parallel with input, so that we will get output is equal to input. Okay. So for all the voltage levels which are less than minus 2 volts, output is equal to input. This is the transfer characteristic equation. Now we have to draw the waveforms. So how to draw the waveforms? Here reference voltage is minus 2. You can remember that one. Below the x-axis we have to mention, and here I am going to draw transfer characteristic graph. So you see here, first condition is what? When VA is greater than minus 2, output is minus 2. Greater than minus 2. This is the minus 2 level. Greater than minus 2 means this entire thing. Okay. So whenever VA is greater than minus 2, output is equal to minus 2. Output is equal to minus 2. Less than minus 2 means output is equal to input. So like this we'll get. Now you see these three conditions carefully. These three circuits carefully. Okay. So this is the first circuit operation. Till here it is the second circuit operation. In these three cases, you can able to see one common point. VR is equal to minus 2 for the third one. Okay. First circuit VR is 0. Second circuit VR is 2. Third circuit VR is minus 2. Okay. So VR is changing. That means reference voltage is changing. Okay. 0 volts, 2 volts, minus 2 volts. But the common point for these three circuits is the input portion which is above reference voltage has been clipped. Input portion which is above 0 volts has been clipped. Input portion which is above 2 volts has been clipped. Input portion above minus 2 volts has been clipped. Okay, so common point for these three circuits is the input voltage levels which are above the reference voltage are clipped. That's it. Okay. The operation of all these three circuits is same. Above the reference voltage will be clipped, below the reference voltage will be transferred to the output. That is a key point you have to remember. So, for your analysis, I can tell here simply summary points regarding the three circuits. So, three shunt clippers we have taken. So, in the first case, reference voltage is 0. You can take this one directly. N side is directly grounded. Like this you can take, or 2 volts you can take, or minus 2 volts you can take. Okay, this is Vi, this is V0. So what is the node point you have to remember? The node point is, for this particular circuit, input voltage Vi, which is greater than Vr, will be clipped. You need to remember just this statement, then this entire three circuits operation will be over. The input voltage which is greater than or which is above reference voltage will be clipped. That means below reference voltage will be transferred. Okay, so if you take 0, first circuit is over. If you take 2 volts, second circuit is over. If you take minus 2 volts, third circuit will be over. So if you take 0, how you will get? So this is the input waveform I am taking. If you take 2 volts, how you will get? If you take minus 2 volts, how you will get? Once again I will draw here for your convenience. So 0, above 0 will be clipped. So this is the portion. This is the portion that is above 0. This is the portion that is above 0. This is the portion that is above 0. Okay, all positive half cycles. But whenever you are taking above 2 volts, so this is the reference I am taking. For minus 2 volts, this is the reference I am taking. Okay, so what we can able to understand here, above 2 volts means this portion, only this portion, above to this portion, above to this portion. Next, above minus 2 means entire positive portion will come, and along with that one this portion also will come. This portion above minus 2. So according to that particular conclusion, what we can tell, the input portion, the input voltage which is above reference voltage will be clipped. So in the first case reference voltage is 0. In the second case reference voltage is 2. In the third case reference voltage is minus 2. So above reference voltage will be clipped and output is equal to Vr only. So this is Vr, this is Vr, this is Vr. That is 0. And below portion will be transferred to the output. So output is equal to input. Like this you will get. Output is equal to input. Exactly you have to turn. So above portion will be clipped to Vr. Below portion is as it is you will get. Above portion will be clipped. Okay. So above portion will be clipped. Below portion will be transmitted. So one common point is same. That is, when Vi is greater than Vr, okay, output will be clipped. So the portion of the input signal which is above Vr will be clipped. The portion of the input signal which is above Vr is clipped. Okay. So that is the conclusion we can able to give for these three circuits. Next, just we will reverse the diode. What will happen, we'll see. I have reversed the diode, and in this case you can able to consider Vr is equal to 0. This is Vi, resistor R, diode D. So operation you can able to follow in the same procedure whatever we have done in previously. So here Vp is equal to 0, P side is grounded, but Vn is equal to Vi. So first if you try for forward bias condition, generally we need Vp is greater than Vn. So here already Vp is 0, so Vn must be negative. Okay, Vn must be negative. That means Vi must be negative. So Vi is less than 0. Okay, this is satisfying the forward bias condition only. Vi is nothing but Vn, which is less than Vp is 0. So forward bias condition only we are getting. So Vi is less than 0. Then diode will get forward bias. Then the diode can be replaced by short circuit. So resistor is there. This is short circuited. Output is across the short circuit is equal to 0. Next, reverse bias condition. If you see, we have to take in the reverse manner, that is VA is greater than 0. That means input is positive. So diode will get reverse bias. Diode is replaced by open circuit, and we know the resultant of this particular circuit when the diode is open circuited. So VA is there, which is greater than 0, and here V naught. Since it is open circuit, there is no current flow, there is no voltage drop across the resistor, so output voltage is equal to input voltage. So here, what is the transfer characteristic curve? Sorry, equation is nothing but when VA is less than 0, output is 0. That means for the negative values of the input, there is no output. For the positive values of the input, VA is greater than 0, output is equal to input. Like this will get. So, if you draw the input and output relationship using time domain graphs and normal transfer characteristic equations, you will get like this. So on x-axis VA, on y-axis V naught. So for the when VA is less than 0, what is output? Output is 0. So less than 0 means negative half cycles, output will become 0. For the positive half cycles, output is equal to input. Output is equal to input. Okay, exactly you have to draw. Output is exactly equal to input. So for the positive portion, output is equal to input. That means y is equal to mx. For the negative portion, output is equal to 0. So like this we have to draw. Okay. Now we have to repeat this operation by taking certain non-zero reference voltage. Okay. By taking certain non-reference, non-negative voltage. So resistor like this I have taken, and you can take here 2 volts battery. That means that VR is equal to 2 volts. So simply we can able to tell when VA is less than 2 volts, we can tell diode is under forward bias. Diode is under forward bias. It can be replaced by short circuit. If you replace with short circuit, in the output you will get only 2 volts. Short circuit means 0 volts plus 2 volts is equal to 2 volts. When VA is greater than 2 volts, what will happen? Diode will go to reverse bias. Okay, because N side voltage, P side voltage is 2 volts. If you have more voltage at the inside, diode will get reverse bias. It will be open circuited. We know when diode is open circuited, no current flow through the circuit, so no need to consider the resistor and the battery. So at that time output is in parallel with input, so output is equal to input. Okay, so if you draw the waveforms, you will get like this. This is the input with reference voltage 2 volts we need. This is the reference voltage with respect to time, and transfer characteristic curve will be like this. Okay, I'm going to draw that one. So when reference voltage is 2, I have mentioned that one. When VA is less than 2, output is equal to 2 volts. So here it is 2, here it is 2, here it is 2. For all the values of the input which are less than 2. For all the values of the input which are above 2, that means VA is greater than 2, output is equal to input. Like this you will get. Okay. Then that one we have to mention. So 2 volts, 2 volts. When the input is greater than 2, output is equal to 2. Sorry, output is equal to input. So straight line passing through the origin. But it should not passing through the origin. If you extend this one, it should passing through the origin because the condition is above 2. But whenever the input is less than 2, output is equal to 2. So less than 2 means left side part of this one, output is equal to 2. So like this you will get. So next, take negative reference voltage. Same circuit, but negative reference voltage we are taking. That is minus 2 volts. Okay, VR is equal to minus 2 volts. So when VI is less than minus 2, what will happen here? In this case, diode will get forward bias. Okay, I will write here. Diode will get forward bias, short circuited. So output is equal to minus 2 volts you will get. When VI is greater than minus 2, diode will get reverse bias. Reverse bias means already we know open circuited. So output is in parallel with input. Okay. So if you take the waveform and the transfer characteristic curve, how you will get? Quickly I will draw here VI, V naught. Next, if you change the color, for what values of input will get output is equal to minus 2. So minus 2 reference voltage I am taking for all the voltages which are less than minus 2, output is equal to minus 2. So like this you will get minus 2. For all the voltage levels which are above minus 2, output is equal to input. So like this you will get. Okay, just if you observe these two, because on this slide you have two circuits. So in the first case, the reference voltage is 2 volts. In the second case, reference voltage is equal to minus 2 volts. So what is the common point you can able to observe here? Okay, before going to tell that one, I will draw this transfer characteristic curve also, because we have compared here input with minus 2. I will take the minus 2 here on the transfer characteristic curve. Next, when input is less than minus 2, that means left side part of this particular VI is equal to minus 2, output is equal to minus 2. When VA is greater than minus 2, output is equal to input. So that we can able to draw like this. This is just straight line passing through the RCN. Okay. Okay. Now, what is the common point we can able to observe in between these two? In the first case, that means in this particular case, output is equal to, reference voltage is equal to 2 volts. How did you get the output? The portion of the signal which is below 2 has been clipped, above 2 has been transferred. In the second case, the input voltage which is below minus 2 has been clipped and above minus 2 has been transmitted. So what is the common point in these two? Okay, we can able to tell what is the common point in these two circuits. The input voltage which is less than reference voltage has been clipped. That is the common point. Less than the input voltage which is less than the reference voltage has been clipped. That is the important point we have to remember here. So till now we have seen 6 circuits. Those 6 circuits I will give here. Resistor. This is the first circuit with reference voltage 0. So for simplicity I will take here it is equal to 0 volts, 2 volts, minus 2 volts. Later we have seen 3 more circuits just by reversing the diode, and 3 different reference voltages we have to provide, like minus plus VR, it is equal to 0 volts, 2 volts, minus 2 volts. Okay, that means this is representing 3 circuits with 3 different reference voltages. So it is also representing 3 circuits with 3 different reference voltage levels. So this circuit, the first circuit, whatever I have given with 3 different reference voltages. So what is the common point we can able to give? When input is greater than the portion of the input signal which is above reference voltage will be clipped. That's it. Will be clipped, and output is equal to, further information, V0 is equal to VR. For the next 3 circuits, when input is less than VR, output is clipped and output is given by VR. That's it. Okay, what is the simple technique we have to remember? If P side is upside, the above portion will be clipped. The P side is downside, below portion will be clipped. P side of the diode, if it is in alignment with the output, otherwise you can able to take like this. Okay, the sign of the output is similar to the sign of the P side. P side, N side, anode, cathode, plus, minus. So if the output sign is the output voltage sign and the diode signs, if both are same, then we can able to tell the above reference voltage will be clipped. If these two are opposite, then you can able to tell below portion will be clipped. Like this, you are taking output from this node to this node. Okay, from here to here you are taking, but here diode is reversed. N side is upside, P side is downside. That means cathode, anode. Okay, so these two are opposite. So the portion of the signal which is below the reference voltage will be clipped. Above the reference voltage, below the reference voltage, like that you have to remember. Above the reference voltage, and in this case below the reference voltage will be clipped. Okay, very easily you can able to do this one. Next circuit we will take combination of these things. That means above certain reference voltage level, that means P side is upside, that reference I will take 2 volts again, and below, for the same signal below also I have to clip. below certain reference voltage level, that is minus 2 volts. Okay, so the combination of these two things we have taken in the same circuit. Since we have here two diodes, the two level clipper we can able to obtain. Okay, this is example for the two level clipper. Two level clipper. Okay, so now you can give here diode D1, diode D2. I am looking for the on condition of the diode D1. So VI is greater than 2. When VI is greater than 2, D1 will go to forward bias and D2 will go to reverse bias. Why D2 will go to reverse bias? Because here N side is connected. P side is connected to minus 2. So to get the forward bias of the diode D2, the N side voltage must be less than minus 2. But how much you are applying? Greater than 2 volts you are applying. If you take it is greater than 2, then Vp1 is greater than 2 and Vn2 is also greater than 2. Vn2 is also greater than 2. This is for diode D2. This is for diode D1. So because of this one it will go to forward bias and because of this one it will go to reverse bias. Because of this one it will go to reverse bias. So reverse bias means open circuit. Okay, here I will write open circuit. Forward bias means short circuit. Okay, so what is the equivalent circuit here? You will get like this. So resistor is there, diode is short circuited D1, here battery is available 2 volts battery and diode D2 is open circuited, here minus 2 volts battery is there. I said whenever current flow is not available, you no need to consider that particular element. So here there is no current flow, so you no need to consider this minus 2 volts. I is equal to 0. So output is in parallel with 2 volts, so output is equal to 2 volts only you will get. This is possible whenever VI is greater than 2. Now you take VI is less than 2. When you take VI is less than 2, diode D1 will go to reverse bias, D1 will go to reverse bias, D2 will go to forward bias. So D1 is replaced by open circuit, D2 is replaced by short circuit. Okay, so since D1 is open circuited, you no need to have any operation because of this particular 2 volts battery, and D2 is short circuited, here minus 2 volts battery we have to take. So output voltage now is exactly equal to minus 2 volts. So this is actually case 1. This is case 2. Okay. So in case 3, we have to take the input voltage which is in between minus 2 to plus 2. Okay. Now for your convenience, once again I am drawing the diagram. Here 2 volts we have given and here minus 2 volts we have given. For example, if your input voltage is in between minus 2 to plus 2, that means I am taking 0 volts for example. So here 0 volts you have provided. So when you provide 0 volts, what is the status of the diode D1? To get a forward bias of the diode D1, you should apply more than 2 volts. But you are applying just 0. So D1 will go to reverse. What about D2? To get D2 on, you need to apply inside voltage is less than minus 2. But 0 is greater than minus 2. So D2 also will go to reverse bias. So both diodes are open circuited. Both diodes are open circuited. So diode D1 is open circuit, diode D2 is open circuit. So if you draw the resultant diagram, D1 open circuit but in series with 2 volts, D2 open circuit but in series with minus 2 volts. Since there is no flow, you no need to consider this battery and this battery. So here VI is there which is in between minus 2 to plus 2 and V0 is in series with VI because is in parallel with VI because I is equal to 0. There is no voltage drop across the resistor. So V0 is equal to VI you will get. This is for minus 2 to plus 2. So if you take the waveform like this, for example, it is plus 5, it is minus 5. We have dealt with the 2 volts reference. So minus 2 plus 2 I have taken. This is VI, this is V0, 2, minus 2, 2, minus 2. So what are the three cases we have? Once again I will write here, when VI is greater than 2, output is equal to. When VI is less than minus 2, output is equal to minus 2. When VI is in between minus 2 to plus 2, output is equal to input. When VA is greater than 2, output is equal to volts. When VA is less than minus 2, output is equal to minus 2. When VA is in between minus 2 to plus 2, output is equal to input. So like this you will get. That means we have clipped the input signal on both sides. That means it is two level clipper. But always you no need to have one clipping level is positive and second clipping level is negative. You may have the both clipping levels positive only or both clipping levels negative only. How it is possible? So what you need to remember, if the P side is upside, that is responsible for clipping above the reference voltage. So for example, about 4 volts I have taken. If your N side of the diode is upside, then it is responsible for clipping below. That means I will take here again positive voltage, that is 2 volts. Okay, both reference voltages are positive voltages only, but operation is same. Okay, here V0 we have to take, this is VA. So this portion is responsible for clipping above 4 volts, and this portion is responsible for clipping below 2 volts, not minus 2 volts. 2 volts we have taken. So without doing any operation, with this particular knowledge, clipping above and clipping below, we will do one thing here. So this is 2 volts, this is 4 volts, both are positive references only. That's why I have indicated like that. It is voltage. Okay, this is 2 volts reference, this is 4 volts reference. So what will happen when input is above 4 volts? Okay, according to the diode D1 operation, we'll get 4 volts only. 4 volts only. Okay, next, when the input is less than 2, according to the D2 operation, we'll get output is 2 volts. So less than 2 means this portion, less than 2, less than 2. When input is in between 2 to 4, 2 to 4, this is VA is less than 2 and this portion is VA is greater than 4. Okay, so now when the input is in between 2 to 4, both diodes will be in the off state. Both diodes will be in the off state and will get output is equal to input. Same thing. But here two reference voltages are positive only. You can take both reference voltages are negative also. Okay. For example, you can try this one. Just I will give here. It is responsible for clipping above. Okay, clipping above I will take minus 1 volt. This is for clipping below. I will take here one more negative voltage, that is minus 3 volts. Okay. So above minus 1 volt and below minus 3. That means you will get the waveform in between minus 3 volts to minus 1 volt. Okay. So this is the thing you have to remember. So we have done few circuits. We have done few circuits with the PN diodes. Okay. Now we will see one circuit with a zener diode. But using single zener diode itself, we will get a two level clipping. Okay. Before going to see the operation of this particular circuit, you need to know the region of operations of the zener diode. So VI characteristics of the zener diode, if you see, forward bias are similar to PN junction diode, but reverse bias we will be having the breakdown where it is less than 6 volts only. Below 6 volts only, zener diode will get breakdown because of the high doping concentration. Okay, so here comparison of the forward bias, this PN diode and zener diode I will take. Okay, so if it is in forward, and two cases are there, ideal, practical. Ideal means short circuit. Zener diode is also short circuit. Okay. Practical means we have to replace the diode with a battery and one resistor, forward resistor. So this is V gamma. This is actually V gamma. So V gamma is the cut-in voltage. Around 0.6 you can able to take for the silicon diode, and 0.2 or 0.3 you can able to take for the germanium diode. But this arrangement should be like this. The P side of the diode should be taken from positive terminal of the V gamma, and N side should be taken from negative terminal of the V gamma. But because this RF is very low, the voltage drop across this particular RF can be neglected. So you can able to take the diode equivalent circuit, practical diode equivalent circuit in the problems itself is just V gamma. Like this you can take. Okay. Now coming to practical zener diode in forward bias. As I said, the forward bias characteristics of zener diode and PN junction diode both are same. Here also same thing. Cut-in voltage, V gamma and battery RF. If you neglect RF, you can able to take the diode like this. We using only V gamma. That's it. So it is equal to V gamma only. This is about forward bias. Okay, ideal diode, practical diode. Since the forward bias characteristics of zener diode and PN junction diodes both are same, the equivalent circuits are also same. But in reverse bias of the zener diode, we have the breakdown below 6 volts only. But in case of the PN junction diode, the avalanche breakdown will be happening, that is at large reverse voltages. So you no need to have that one here, because that much reverse voltage will not apply practically. So it is a zener diode, but zener breakdown will be happening just the reverse voltage which is just beyond the 6 volts or the breakdown voltage. Okay. So in the reverse bias of the zener diode, you have to include this breakdown region also. This is a non-breakdown region, whatever I am highlighting here. So this point is very important for us. So in this particular non-breakdown region, the current is zero. Current is zero means you can take open circuit. But whenever it is reaching this particular breakdown region, the current is drastically increasing at fixed voltage, that is the breakdown voltage. So the equivalent circuit of the zener diode in the non-breakdown region, it is different from the equivalent circuit of the zener diode in the breakdown region. So we have to be more careful regarding this one. What about reverse bias of the PN junction diode? Because here current is almost zero, we can take open circuit ideally, and practically in the problems also we can able to take open circuit only. Okay, so here I am taking reverse bias conditions. For the PN diode, we are replacing with open circuit ideally, and in case of zener diode, we can replace open circuit. Okay, for the PN diode, this is enough, but in zener diode, it is not enough. We can replace the diode in reverse bias. We can replace the zener diode as open circuit in reverse bias only whenever it is in non-breakdown region only. But whenever it is entering into breakdown region, that means whenever your reverse voltage VR is greater than Vz. I am taking the magnitude of Vz here. So don't confuse with negative symbols. Your reverse voltage is greater than the VR in magnitude. Then the zener diode is entering into breakdown region. At that time, the zener diode is to be replaced by a battery that is equal to Vz only. That means breakdown voltage only. But very important thing is the positive terminal of the battery is towards the inside of the diode. Negative terminal is towards P side of the diode. That should represent the P side of the diode. Negative terminal should represent P side. Positive terminal should represent N side when it is under breakdown. It is different from the cut-in voltage battery. In case of the cut-in voltage battery, the positive should indicate P type, negative should indicate N type. Okay, so this is about the equivalent circuits of the zener diode in forward bias, in breakdown and in non-breakdown. All these things we have to keep in our mind while analyzing the clipping circuits using zener diode. Okay, so already I have given the circuit here. Once again I will draw to analyze that particular circuit. So zener diode, if you take, it can be in forward bias, it can be in reverse bias. In reverse bias, it can be in non-breakdown region, it can be in breakdown region. In forward bias, you can replace with the short circuit. In breakdown region, you can replace with open circuit. In non-breakdown region, if the diode is like this, you can replace by a battery like this. This is Vz minus plus. Okay. So this is for ideal case I have given. So in most of the cases we will use ideal only. Whenever it is practical case, I will tell what to do. Just we have to include V gamma, okay, in the forward bias. That is what you have to remember. So anyhow, that particular circuit I am taking, resistor, this is the diode we have taken, zener diode. Now what will happen? As I said, the forward bias characteristics are same. You can proceed like that only. Here Vn is equal to 0 and Vp is equal to Vi. So when we will get forward bias, when Vi is greater than 0, you are satisfying Vp is greater than Vn. That means the diode will get forward bias. So it can be replaced by short circuit. Output voltage you are taking across the short circuit, that means output voltage is 0. So what is the conclusion we can give here? When Vi is greater than 0, output is equal to 0. So clipping above 0 volts, done. Next, reverse bias. That means this Vi we should apply negative voltage. Now you have to listen very carefully. When you apply Vi is less than 0, surely that is the reverse bias. But whenever you are analyzing about the zener diode in reverse bias, we have two things. One is breakdown region, second one is non-breakdown region. So whenever Vi is less than 0, we get reverse bias. But in that means negative voltage we have to apply. That means, for example, when Vi is less than minus Vz, it will enter into breakdown. It will enter into breakdown. That means if you apply the negative voltage in such a way that is in between minus Vz and 0, then it will be in the non-breakdown region. So minus Vz less than Vi less than 0. So you are not approaching the breakdown in this particular case. So non-breakdown. So diode is under reverse bias only, but non-breakdown. So current is 0. So that means you can able to replace with open circuit. So current is 0. You don't need to have any voltage drop across the resistor. So output is equal to input you will get. Now you enter into breakdown. That means Vi is less than minus Vz we have taken. At that time the diode is equivalent to a voltage source that is equal to breakdown voltage only. But whenever P side is there, that is represented by negative terminal of the Vz. Whenever N side is there, that is represented by positive terminal of the Vz. So output we are taking like this. So that is equal to minus Vz we will get. So what are the conclusion we can give? When Vi is greater than 0, output is equal to 0. When Vi is in between minus Vz and 0, output is equal to input. When Vi is less than minus Vz, output is equal to minus Vz. So two reference voltages we have. Okay, two clipping levels we have. So if you draw the waveform like this, here the portion of the input signal which is above 0 volts will be clipped to 0, 0, 0. Like this we have taken. And Vz you can able to mention like this. The portion of the input which is in between 0 and minus Vz, output is equal to input. Output is equal to input. Like this you will get. The portion of the input which is below minus Z, output is equal to minus Vz. So like this you will get. Okay, here it is, this one. So like this you will continue. So two level clipping we can able to get using single zener diode only. Okay, this is what you have to understand. Now once again, the previous circuit I am taking, this is the circuit we have taken. So when Vi is greater than 0 volts, diode is under forward bias, replaced by short circuit, so output is equal to 0. When Vi is less than 0, that is reverse bias, and in that, if you have the input voltage in such a way that that is less than the breakdown voltage, that means minus Vz less than Vi less than 0. Okay, if you apply like this, then that means the diode is under non-breakdown region. Non-breakdown region means that is open circuited. Okay, open circuited. So no current through the resistor. Voltage drop across the resistor is equal to 0. So output voltage is equal to input voltage. Now next case is when Vi is less than minus Vz. That means you are providing the voltage which is beyond the this breakdown voltage. Then the diode will go to breakdown region, so that diode is replaced by its zener voltage in such a way that negative is indicating the P side. So output is equal to minus Vz. Okay. Now similarly you can take another circuit just by reversing the diode. That's why I have repeated that one here. Replace the diode with reverse the diode like this. So inside is upside. Okay. So when Vi is less than 0, because Vp is 0 here, whenever Vi is less than 0, diode will get forward bias. It is replaced by short circuit. Across the short circuit, if you take output, that is 0. Now you have to apply Vi is greater than 0, then you will get reverse bias. But in that you have two cases. One is non-breakdown case, second one is breakdown case. So non-breakdown means you are applying the input voltage, but that voltage is lesser than the breakdown voltage. Okay, then the diode is replaced by open circuit. Whenever it is open circuit, we know output is equal to input. Now breakdown voltage. To get breakdown voltage, you need to apply the input voltage which is beyond the zener voltage. Okay, or the breakdown voltage. So now the diode is replaced by battery. The positive of the battery Vz is similar to, is should indicate the inside, negative should indicate P side. So you will get output voltage is equal to zener voltage only. So what did you understand here? For negative values of the input, output is 0. When the input is in between 0 and Vz, output is Vi. When input is greater than Vz, output is equal to Vz. Okay, so like this we got. So here also we have two level clipping only. Okay, using single diode we have two level clipping. So once again, if you see, again the same circuit I have taken. Input is greater than 0, output is 0, input is minus Vz to 0, so output is input. When input is less than minus Vz, output is minus Vz. Now we got like this. Second case, next one, we have seen this one also. When input is less than 0, diode is forward bias, output is 0. When input is in between 0 and Vz, non-breakdown region, diode is open circuited, so output is equal to input. When input is greater than breakdown voltage, diode is replaced by a battery since it is in breakdown region, so output is equal to plus Vz we will get. Okay, so if you take the waveforms carefully, so here the input is like this, both are changing with respect to time. So in the first case we compared with minus Vz, because to enter into breakdown region we have to apply the negative voltage here in the first case, and to enter into breakdown in the second case we have to apply positive voltage because n side is upside here. This is Vz. So according to the transfer characteristic equation, you can able to draw the output. So in the first case, when the input is greater than 0, output is 0. Less than minus Vz, output is minus Vz. In between, output is equal to input. So two level clipper. Now when input is 0, in the second case I am talking, when input is less than 0, output is 0. When input is greater than Vz, output is equal to Vz. Input is in between 0 and Vz, output is equal to input. Like this will be. So two level clipping we got because of the zener diodes. Okay. Now back to back connection of two zener diodes I can take like this. Okay. Now how to go for the circuit operation. This is diode D1, this is diode D2. Having the breakdown voltage VZ1, VZ2. So how to analyze these circuits means you have to see for the current flow. Okay, when current flow is possible, current is not equal to 0 in the forward bias of the diode because we are working with zener diodes. When the zener diode is in the breakdown region also, current flow is possible. Current is equal to 0 in non-breakdown region only. First you have to remember these things. Okay, current is not equal to 0 in the forward bias of the diode or in the breakdown of the diode. Okay, so now I am analyzing this one. I need to look for diode D1 should go to forward bias. For that purpose I need to apply VA is positive voltage because P side is upside, VA should be positive. But whenever you are applying VA is positive, reverse bias for D2 will be happening. But you need current flow. That means you need to apply this positive voltage in such a way that D2 should go to the breakdown region. So now through D2 current is possible, through D1 also current is possible. Okay, so what will happen? How it is possible? When VA is greater than VZ2, when VA is greater than VZ2, diode D1 is replaced by short circuit, diode D2 is replaced by a battery. So output is equal to, you will get short circuit is in series with battery whose value is equal to VZ2. Like this you will get. Now again you look for forward bias of the D2. Now you go for the D2. So D2 should go to forward bias. Because D2 inside is upside, your VI should be negative to have the forward bias of the D2. But when you apply VI is negative, since P side of the diode D1 is upside, D1 will go to reverse bias. But in reverse bias, current is required means it should be operated in the breakdown region. Okay, how to get this one? You need to apply the input voltage very negative such that it will go to breakdown region. Very negative means D1 should go to the breakdown means you have to apply VA is less than minus VZ1. VA is less than minus VZ1, then D1 will go to breakdown. So it can be replaced by a battery whose value is equal to VZ1 and D2 will go to forward bias that can be short circuited. So output is equal to, you will get now minus VZ1. Why minus? Because P side of the diode D1 is upside. So that is represented by negative terminal of the VZ1 battery. Okay. Now VI greater than VZ2 is over. VI less than minus VZ1 is over. So when VI is in between minus VZ12 plus VZ2, the diode operations will be nullified. So off condition. So output is equal to input you will get. So for these particular conditions, if you draw the waveforms, so whenever Vi is greater than Vz2, output is equal to Vz2 we got. Vi is less than minus Vz1, output is equal to minus Vz1. When Vi is in between minus Vz12 plus Vz2, output is equal to input. So if you take the waveforms, reference voltage we have minus Vz1 plus Vz2. Okay. So what we have here, above vz2 output is equal to vz2. Next, below minus vz1 output is equal to minus vz1. Above vz2 output is equal to vz2. Whenever input is in between minus vz1 to plus vz1, output is equal to input. So like this we'll get two level clipping we can able to achieve. Okay, so you can able to try for another circuit which is similar to the previous circuit only, where d1 d2 we have taken like this. By reversing those two diodes, you will get the new circuit, that is reverse the d1. So sorry, so once again back to back connection can be given like this also. Okay, this operation you can do for various values of the input. Okay, so with this I am closing this particular session. Thank you.